Good morning, Tamina Khan is here in TKMaths S1. In today's video, we will solve a question on composite function in context of domain and range. And this question is taken from March 18, variant 1-2. So you can see a question here. The two functions are given to you, f of x and g of x, but the domain are different. You can check here, right? First part of the question is saying find the range of the function f. So if you see, this part of the graph is what? Reciprocal function. And you know the shape of the reciprocal is like this. Okay. Now if I look at this function, question is saying the values greater than 2. So suppose, let me erase this part first again. Just give me a second. So this is my x-axis, okay, and this is the y-axis. If I take the values of x here, 1, 2, 3, 4, 5 onward, because x values are greater than 2. So what will happen to this graph basically? So first of all, if I put in this graph, in this equation I mean, if I put 2 here, 2 minus 2 is 0. And h divided by 0 is undefined. Plus 2 undefined. It means at 2 you are getting asymptote here. Agreed? If you take a bigger value, suppose I take any bigger value of x, suppose I take 10. So if I take 10 here, 10 minus 2 is 8, right? And 8 divided by 8 is 1. And 1 plus 2 is 3. So what will happen? I will get here 3 at 10. Suppose this is 10 I got here. No matter which value of x you put here, very big value, 50, 100, whatever, this will go towards 0, very, very small value, but 2 will always be added into it. So the value of y will always be greater than 2. So that's why this is also sort of your, I can say the line, the values of y will be above it. So basically the graph has this shape here. This is just to understand the question, right? So you can say here, what are the values of y on this part of the curve? That is the range of function f. So it is always greater than 2, right? It will never touch 2. So you can write here that the range of the function f is greater than 2. Now let's look at the range of function g. Now we will focus on this part of the curve. Equation and the curve will always be same. So following it only, if you substitute 2 here, you get asymptote, right? So this part of the curve will be same. But if you put 4 here, then what will happen? 4 minus 2 is 2. 8 divided by 2 plus 6. So at 4, suppose this is 4, you will get, this graph I have to draw again. You will get what? 6. At 4, suppose this is 4, you will get here what? 6. Now what is happening? You cannot take value greater than 4. So this is your largest value of x and this is your smallest value of x, 4 and 2. So between 4 and 2, what is the part of the curve? Between 4 and 2, the part of the curve is this one, which is going up here. So for this part of the curve, what are the values of y? Yes, you are absolutely right. It is starting from here, which is 6. So after that, it will all be greater than 6. So I can say that the range of g is, yes, range of g is what? Absolutely right. It is greater than 6. So you can write here, g of x is greater than 6. So I have written this neatly here for you so that you can understand. So range of f is greater than 2 and range of g is greater than 6 for this domain. So now let's do next part. Part C saying find out the range of f of g of x. Now we have just seen in above part that the range of f of x was greater than 2, range of g of x was greater than 6. Now we have to find out the range of g of x. Now remember one thing, for function g, the domain was, what was the function g domain? This one, right? This domain gives you the range greater than 6. This range will become the domain of f. This is the main thing about composite function. Whatever is the range of g for the given domain, that will become the domain of f. So now if in function f I take the values greater than 6, first of all I have to see, is it possible or not? You are right. If I look at this domain for function f, it falls fully within the given domain of f. Given domain of f is x greater than 2. And what we are finding from the composite function? Greater than 6. So greater than 6 come greater than 2, 100%. So composite function is existing. So now if I substitute here 6, which will be my minimum value of y, or maximum, that we will see. So if I put 6 here, what answer will I get? See here, I got 4. So at 6 I am getting answer 4. Now let me increase the value. Suppose I put x 10, because I have to take any value of x which is greater than 6 in function f. So now if I take 10 here in this place, now I'm doing mentally rather than writing. 10 minus 2 is 8. 8 divided by 8 is 1. 1 plus 2 is 3. And after that, if I take here further big value, suppose I take here 16. 16 minus 2 is 14. 8 divided by 14, further is smaller, plus 2. So what is happening? My values of phi is decreasing, but they will not go less than 2, because every time you will adding 2 in it. So your values of y will be from 2 to 4. And that's why you can say the range of f of g of x is, let me write here neatly, the range of f of g of x is in between 2 and 4. Should I write equals to with 4? Yes, I should, because when I substitute 6, but 6 is not included here, equals to is not here, so I will not write equals to with 4. So this is the range of f of g of x. All this what I have explained, I have written here neatly also. I can put a video on pause, you can put the video on pause here and read it out. Whatever I have explained, I wrote it down very neatly here. Okay, now the last part of the question, which is explain why the function g of f cannot be formed. Right now we have seen f of g, but now we have to see function g of f cannot be formed. What is the reason? See here, the function f of x you have seen has domain x greater than 2 and range also greater than 2. This range of the function f will become the domain of g. And what is the domain of g given to us? This one. Do you think this lies fully within this? I am saying x greater than 2. X greater than 2 is fine, but at the same time it has to be less than 4 in the domain of g. So the domain of g, which is given to us here, does not satisfy with this one. So that's why the function or the composite function does not exist, because the main thing is when you get the range from function f which will act as a domain for g, it should fully satisfy the given domain, but that is not the case here, and that is the reason we can say the composite function g of f does not exist. I hope you understood this question. Thank you very much for watching the video. By the way, I said the last part I am not solving it because it is a simple part, you can do it. What is the difference? This means differentiation of function f. This means inverse of function f. So just multiply that by 6 by 2 and then solve like an inequality. If you think it is difficult, you can write in the comment and I'll definitely solve it. Take care. Allah Hafiz.